Already. The schedule. Today we're going to look at compounding interest. We had started outlining the concept last class. We're going to look at also yield and annuity. There is a simple interest quiz that's in my labs that's due on the 3rd, which would be on Thursday. The quiz is in my math lab. There is a drop box for your work in Blackboard. Thinking ahead, exam 4 will be due on the 13th. The final exam will be on the 17th, which would be our last day of classes. It's a Thursday. It will be available from 10 a.m. to 10 p.m. that day. Homework 20 is due on the 3rd, and give me just a second. Homework 20 is, I believe, the homework on percents. So that one you could have done probably a while ago. Homework 22, say that again?
Are we having a project 4?
Yes, we are. And part of me is thinking, oh, should we just ditch project 4? But this class was selected by SUNY to evaluate gen eds, and the projects is how we evaluate the gen eds. So there will be a project 4. Probably introduce it next class, probably be due the last Tuesday of class. I didn't put that in here yet because I don't have that ready to present as yet. Homework 22 is on simple interest. So that again is something that we've done already. You can finish that. Let's list these. Homework 23 is on compound interest, and that's what we're doing today. So after today, you should be able to do that. Homework 24 is on annuities. That one we will cover on Thursday. So after Thursday, this Thursday, which would be the 3rd, that one should be fair game. And then homework 25 and 26 are on fixed payment loans. And those we should be covering on the 8th, so that after the 8th, that should be fair game. So, so is that what you guys were looking for in terms of, you know, rolling due dates? If I were to move due dates, this one would also be due on the 3rd. This one would be due on the these ones would be due on the 8th, and well, actually probably most, and these two would be due on the 10th. So these two are very closely related. They use the same formula. Just the first assignment is in terms of cars and car loans, and the second one is in terms of mortgages. In terms of that project 4, what it will involve, it's, yeah, that last project was kind of just like homework, but using real life data. This is going to be a project where you have to either look online or in the newspaper or Zillow or somewhere and find a house that you want to buy, and then use the formulas that we'll be coming up with in that loan payment section to figure out what the mortgage payment would be for a 15-year mortgage and a 30-year mortgage at the current interest rate in Niagara County, which you'll look up the day you do the project because those interest rates vary daily, and then decide which is the better choice. So it should not take too terribly long to do. You know, it's something that probably could be, you know, knocked out in half hour, 45 minutes once you get your house picked up. Does anybody have any questions on any of these dates? And does anybody have any questions on any homework? No, two people are in the waiting room. Gina and Michaela. Let me add them to attendance while you guys think about whether you have a question or not.
I was doing homework 20. Well,
Uh-huh.
no, I was doing homework 27 last night, and I was confused. I didn't
There
realize.
isn't a homework. There isn't a homework 27. The last one is 26. 21, I did not assign. We're not looking at,
It said 27.88. 8.8. And it's due the 12th of the 10th.
there isn't a homework 27, 8.8.
What the hell am I looking at then?
I don't know. Because I'm looking here at the list of all of the assignments. And the last one is 26, 8.7. And we haven't covered that yet.
Well, I don't know. That's what I'm seeing though.
Can you do me a favor? In that assignment, just pick one question and just hit the email my instructor button. And I'll look in my email and see what you're talking about.
Okay.
Okay?
Mm-hmm.
And do you promise me you'll stop me 5 minutes before the end of class and force me to check my email and check on that and see what you're talking about? Are you
Yeah.
all right if we put that off till the end of class?
Yep.
Okay, so we go until 9:15. So let me set an alarm on my phone just in case. Clock. We
I
want an
sent
alarm.
it to you.
Okay, thank you. And we want an alarm to go off at 9. And by the time I finish playing with my phone, I probably could just check my, here it is, email. I got it. Homework 27, 8.8.
I told you. Well, at least I got 2 questions right. I got 50.
Oh,
We should do it at the end of the class.
oh, credit cards. Yes, we're not covering the credit cards. Don't worry about that section. We're not covering the credit card section. I don't know how that would have shown up in your homework.
I don't know.
I apologize. Okay, so that's the average daily balance for a credit card, which is really interesting and pertains a lot to your life, but we don't have time for it. I don't know how that showed up in your assignment because in my list of assignments for this class, it's not there. So
do it
I
for-
apologize for that, Chris.
Okay.
Okay.
Mhm.
I will double check and make sure that that is definitely not assigned.
Okay.
But it's not showing up in my assignment manager, which is supposed to be the list of all of the assignments for the semester. That's really weird. I'll double check that for you. Does anybody have any questions on homework 20 or 22? If not, last class, we ended up looking at the idea of compound interest. And we had said that that was when you make interest on the interest. And we looked at an example where we were compounding at the end of each year over the course of 3 years, and we saw that that involved doing 3 separate computations, one for each year, but in adding the interest to the principal, it gave us more interest in the end. Does everybody remember being there? When we compound, we look at different periods, which tells us how frequently we compound. When we look at the formula for compound interest, we introduce a new variable, n, which is the number of compounds in 1 year. And so if we compound annually, that means once a year, so n is 1. If we compound semi-annually, then n is 2. It means twice a year. Instead of I compound quarterly, quarterly would be how many times a year? Any ideas?
4.
4, beautiful. Then next is monthly. And monthly would be 12 times a year. And then last that we'll look at is daily. And again, compounding daily, we're going to use 360 times a year using that banker's year. And so when I look at compound interest, we looked at compounding over 3 years annually, and we did it 3 times. If I were doing it 3 years monthly, I would have to use that, like figure things out 36 times. 3 years daily would be 360 times 3. I think that would be like 1,080 times. You kind of start getting like, unmanageable. And so we have this formula that says that the A is equal to P times 1 plus R over N to the NT. A is the future value. P is the principal. R, you know what, let me be consistent between uppercase and lowercase. R is the rate. And again, we want to express it as a decimal. N is the compounds in 1 year. And T is the time in years. So let's look at an example. Does everybody have this written down? Can I keep going, or do I need to shut up for a minute?
I have it written down.
I have it written down.
Okay, so let's say that, like those last examples we looked at last class, we want to invest $1,000 at 5% interest. Let's say this time we're going to compound monthly. for last class, we were looking at 3 years. Again, with these problems, because the lion's share of the work is done by your calculator. Oh dear, and I'm in a panic because right now I don't see the calculator. Oh, I got it. Calculator that is comparable to what you guys have. Write the formula. A equals P times 1 plus R over N to the NT. Identify your variables. P, my principal here, is at $1,000. R, my rate is 5%. But remember, we have to write that as a decimal, so we're going to use 0.05. And if I'm compounding monthly, that's 12 times a year. T, I'm doing this for 3 years. And then I have to say that sometimes when I'm typing these formulas in, I reach a limit as to how many times I want to use my parentheses keys. So I find it easiest over here with this exponent. If when I define my variables, I take the time to multiply n times 2, which would be 12 times 3, or 36. Again, it's not essential that you do that, but if you don't, you need extra parentheses. So I would strongly suggest you multiply n times 2 before you substitute that exponent into the formula. Everybody with me so far?
Yep.
So substituting, I'm going to get 1,000 times parentheses 1 plus 0.05 over 12 raised to the 36th power. Now, in terms of how you'll do this with your calculator, I would type in 1,000 times, open parentheses, 1 plus 0.05 divided by 12, close parentheses, and I think most people, to raise to a power, use that caret up button on the calculator, 36. Again, if you didn't pre-multiply, you would have to have parentheses 3 times 12. So I think it's easier if you just type in that exponent as 36. And then doing this, the 1,000 times parentheses 1 plus 0.05 would help if I press the right button, divide it by 12, close parentheses, caret up 36. I am getting 1161.472231. Because it's money, we'll round to the nearest cent, unless we're told otherwise. And so we'd be getting $1,161.47. Did everybody else get that same result with their calculator?
Yes.
Great. So then the question becomes, how much interest did we earn? And with these problems, the interest is going to be the difference between the final value and the initial value. So that the interest is that future value minus that initial value, or that principal, or we earned $161.47 interest. Now, if we compare that to what we got last class, compounding annually, last class, with the same dollar amount and interest rate and time, when it was compounded annually, we earned $157.63. It's not that significant of a difference, but it's more. And so the more frequently you compound, the more interest you earn. If everything else is held fixed, if the time and the interest rate and the principal are held fixed. So let's try another example and see how you folks do. This time, let's say we invest $9,500 at 6% compounded. This time, let's say we're going to compound quarterly for 5 years. Let's find the future value to the nearest cent. And the total interest. And again, we're using that formula A equals P parentheses 1 plus R over N close parentheses to the NT. You need to identify P, R, N, T. And again, I strongly recommend you multiply out NT, substitute in, and let me know what you get. Give you guys a minute to work this one off. Christina, as you guys are working, I'm checking my my math lab assignment manager and gradebook, and I see in the gradebook that you're working on that assignment. But from my end in the assignment manager, I see that I deleted that assignment. So I have absolutely no idea what's going on there. It's
Wait, the
very much.
homework 27?
Yeah, I see that you worked on it, but I also see it doesn't show up because I deleted it. It doesn't show up in the assignment manager. So I have no idea what's going on. So nobody do homework 27. Oh boy. But anyways, what type of answer are you guys getting for this one?
I got 12,795 and 12 cents.
Beautiful.
And then for the interest,
Mhm.
I got $3,295.12.
And I like it. Does everybody else like it? Yep.
Yeah.
Okay, and so that's pretty cool. You're making $3,000 for doing nothing but putting your money in the bank. So now next one's a little bit different. We talked about how the more often you compound, the more interest you make, right? So let's picture two banks across the street from each other. One does simple interest. The one across the street compounds annually. So people flock over there because they make more money. Then the other guy does quarterly. So then the other guy does monthly. So then the other guy does daily. Well, why stop there? Maybe the next guy does every hour. And maybe the next guy does every minute. And then maybe the next guy does every second. And can you picture trying to, the number of seconds?
So much.
Thing. And so instead we get to an idea that's called compounding continuously. And when you compound continuously, you're constantly adding the interest to the principal. And in order to do this, we need to look at a new number. Now, can I go on the assumption that everybody in class has heard of the number pi? And pi is 3.14159, and it goes on and on and on and on and on. And it's an irrational number. And so we use that symbol pi to write it instead of the digits, because the digits go on and on and on and on. There's another irrational number like that. And its symbol is a lowercase e. And E is named after a famous, I think he was German, mathematician, philosopher, Euler. And it's called Euler's constant. And Euler's constant is given a definition. It has meaning in calculus. It's defined as the limit as the numbers get larger and larger and larger, goes to infinity, as 1 plus 1 over n to the n, which you don't really need to know. That's just an aside as to what it equals. E is on your calculator, but it's hidden a little bit. Can everybody please take your calculator and look at it? Somewhere on your calculator, you see a button log. Does everybody see their log button?
Yes.
Near the log button, there is another button, LN. Can everybody find the button LN that's near the log button? In tiny print, above the LN button, there should be written e to the x. And that's where you find E on your calculator. Because it's in that tiny print above, you have to first press, depending on the brand and model, either second or shift. Then press the LN button. When you do that, you get something that looks like E caret up or E with an exponent. And then actually my calculator opens up parentheses. So type in that number 1. What does E to the first power look like? It turns out to be something like 2.7182818, and they just keep on going. It's an irrational number.
Mine just gives a regular E.
It doesn't give you a value?
No, it just does the regular letter E.
When you press equals, it doesn't change it into a decimal.
No.
Okay, what type of calculator do you have?
I have a scientific calculator.
What brand?
Data X.
Okay, that has something to do with the mode of your calculator. Let's see what it does when we use it to evaluate the formula. We might have to play around with the mode if it leaves it in terms of E, but we'll see.
I have the buttons that you said, but I pressed it, but it just comes up as the letter. There's nothing
Okay.
after.
Well, let's see what happens when we use the formula. So this formula for compounding continuously is A equals P E to the RT. Again, P is my principal. R is my rate as a decimal. T is my time in years. And A is my future value. And so let's say we're going to invest, I don't know. How much money do you guys want to invest?
100,000.
$100,000. And, oh, let's make it crazy, like 3.5% interest. Compounded continuously. Or, oh, let's leave it in there for 5 years. When I see that compound continuously, I know I need this formula with E. The principals are 100,000. The rate as a decimal is 0.035. Be careful. Remember to move that decimal point to change the percent to a decimal. And our time is 5 years. And this time I'm not going to pre-multiply that exponent because I know on my calculator, when I press that E button, it opens a parentheses. And so with my calculator, I'm going to type in 100,000 times, then I'm going to press that second or shift button, LN. Then it's going to open a parentheses by itself. I'm going to type in 0.035 times 5 and close my parentheses. So that's what I'm typing, not what my display looks like. So 100,000 times second ln, and it gives me that e to the power. It opens the parentheses, so I'm just going to multiply 0.035 times 5, close my parentheses, and so I am ending up with $119,124.62. Michael, did you get an answer like that, or did you get an expression with E in it?
You're asking me?
I apologize, I'm asking the wrong person. I thought I heard a different voice. You were saying that they only got the E.
Yeah, me, I'm still getting.
Zach, I'm sorry.
No, I'm just
I'm
kidding.
sorry, Zach. Are you getting something with E in it, or are you getting a decimal, numeric answer like this?
Well, I'm trying to type it in like the 100,000 E, but it's not with any parentheses after the E. It's just doing the regular E.
And then there's a caret up for an exponent?
No, there's nothing after the E. It's just an E.
Okay, when you look at the display next to the E, where you're gonna type in next, is it elevated like an exponent?
It shows like a little D.
Okay, I'm gonna stop sharing for a minute. I'm gonna put it on speaker view. I'm gonna ask you to turn your camera on and hold your calculator up so I can.
Wait, I think we have the same calculator. I think he's pressing the wrong thing.
Yeah,
Okay.
I think, yeah. I have like this one from Tops. It's a scientific one. It's
The Casio.
yeah.
Mm.
Press the
So-
exponent button.
The one that said like, it looked like it said in, but it's not in. It's
Yeah.
LN. That's the one.
Were you supposed to press a button before that?
Yeah, shift. Press shift first, and then you press that button that looks like it said in, but it's LN.
Yeah. Yeah,
You see it?
that's what's coming up is just the E after the 100,000.
Okay, so what you want to
Yeah,
do?
so the 0.035 now times the 5. Oh, sorry.
Can I see what yours looks like now, Zach? Okay, you have to talk for a minute so I can see you. So
Yeah.
I'm still seeing Chris. You might want to press whatever you use to get an exponent before you type that number in.
No, but that's the same way mine's look.
Okay, well then listen to Chris and I'll shut up.
No. Okay, so I typed the 100,000, right?
Yep. Yep.
So that's it. Then I type shift the EN button with the little E. So then it's
Yep.
gonna look like that.
Yeah.
You see that?
Yep.
All right. So then
Yep.
after that, I type in the 0.035 times 5, and then it looks like that. You can see it?
Yeah. It's not doing that for mine. It just keeps.
Yeah,
going.
yours isn't going into exponent.
Yeah, it's not going to, because I keep doing the shift.
So
Uh,
where you have the E, Zach, what
Yeah.
button do you push to raise something to a power with yours?
like an exponent.
Uh-huh.
You mean
Do you have
like
a
this?
caret?
Like.
Yeah,
Oh, yeah, yeah.
now open parentheses, 0.03, you need the parentheses
Okay.
around it,
Oh,
0.035 times 5.
like that.
Wait, I thought we had the same.
No, he's got a slightly different model.
No, I got.
Ah, all right.
So Zach, can you show me yours again, please? Can you talk?
Yeah.
Okay, now hit equal.
I was doing syntax error.
Okay, can I work with you after class to try to get your
Yeah.
calculator to work?
Yeah.
Okay, so stick around for a couple minutes after class and we'll try to pull up the manual for that one.
Okay,
Okay?
yeah, okay.
And so back to the problem at hand, what was our total interest?
$19,124.62.
Right, because we're gonna take our final amount and subtract what we invested. And so we get that $19,124.62. And so again, remember that if you see those words compound continuously, we need that formula with E. Again, for this test, because it's going to be in my labs, I can't put the formula sheet in the test. I will have in the folder with the test a formula sheet for you that I would strongly suggest you print out and open up before you start doing the test in my labs. Just like I had those couple diagrams with the last test in there.
I'm sorry, can you repeat that? What did you say? You have what?
You're going to have a formula sheet in Blackboard.
Formula sheet in Blackboard?
Right. I will
And
put
then-
it in there before the end of the day today. That you
Okay.
can use for any test or quiz.
Okay, and then the quiz is due on the 3rd, right?
Right.
Okay.
So now another type of compound problem. Whoops, that's not what I wanted to do. I wanted to add a page. This time, let's say I want, not me. I'm too old for me to want this. You want $500,000 in 30 years. 30 years, you guys are going to be ready to retire. You're going to want $500,000, $500,000. You can right now invest in an account that pays 4% interest compounded monthly. How much should you invest now? And before we answer this question, I'd like to do a tiny bit of algebra. This is letting me see somebody is like not muted and you're getting the echo. So if you could check yourself. We have the formula A equals P times 1 plus R over N to the NT. And this is all fine if we know P and we're looking for A. We want a different formula if we know what we want in the future and we're looking for P. In order to get that, I'm going to do a little bit of scrap work on the side. Let's say I had a slightly different formula that said that A is equal to P times something. I'm going to call it C. If I wanted to solve this formula for P, is everybody all right? I'd have to try to undo the multiplication by C, and I divide both sides by C and get P is equal to A divided by C. And these two formulas would be equivalent. Is everybody sort of comfortable with that level of algebra?
It confuses me a little bit, but I think I understand
we're just going to divide out what's the P is being multiplied by in order to get the P alone. We end up doing the exact same type of work over here, but instead of it being a pretty single variable, we've got that ugly expression. And if we were to divide both sides by that ugly expression, don't let it hear me call it ugly, we would end up with something that says P is equal to A divided by that quantity we were multiplying P by, 1 plus R over N to the NT. And so we're going to use this formula if we know A and are looking for P. And so we'll have two different formulas for compound interest. If you add the continuous one and the yield one, we'll even have more. But I digress. So in the question we just outlined, we're going to use this formula, P equals A over parentheses 1 plus R over N, close parentheses to the NT. And we know that we want that $500,000 in the future. That's our future value. Our rate, now I'm double checking myself, yeah. Our rate is 4%, so that'll be 0.04. We're compounding monthly, so N is 12. And we want that money in 30 years when you guys retire. How much money would you have to put in the bank now in this account in order to have that money when you retire? Substituting into this new formula, I'll have that 500,000 divided by parentheses 1 plus 0.04 over 12. Whoops, and I forgot. We want to figure out that NT in advance. 12 times 30 would be 360. And so again, this is one of those things that I would not want to do by hand without a calculator, because thinking of taking that crazy decimal and multiplying it by itself 360 times makes my head hurt. But the calculator will do that for us. We're going to type that in just as it looks. We're going to type the $500,000. Then we're going to type the division symbol, which will end up looking like a slash. Then we're going to open the parentheses, 1 plus 0.04, again, divided by, looks like a slash, 12. Then we're going to close the parentheses and raise it to the 360th power. And is anybody else getting that we'd need 150,897.9326? And then we have to add something important here. When you, to solve for P, you're always going to round up. So if I were to round this to the nearest cent, I would instead have $150,897.94. And again, the reason we're always rounding up is because if we round it down, in 30 years, we wouldn't have our full $500,000. We'd be short because we round it down. If we round up, we might have a little bit more than that 500,000. But if we round it down, we would have less. And so when we're solving for the principal, we're always going to round up. So does everybody have a spare $150,897.94 that they can throw in the bank and let stew for 30 years?
No, ma'am.
No. But let's stop and let's look at this from the positive side. How much interest will we have earned? Well, again, the interest is the difference between the future value and the present value. And so if I take that $500,000 that we're ending up with and subtract from it the $150,897.94 that we started out with, what are we getting for interest?
$349,102.06.
And so look at the interest is more than double the money that we put in. That's a lot of money to make just for waiting. But again, the problem is that most people don't have that $150,000 now. And so that's going to lead us to that next topic, annuities. But before we look at annuities, there's one more thing we need to do with this compound interest formula. And it's the ability to compare different investments. For example, I might have a question that says, which is better? %, compounded monthly, or 8.25% compounded annually. And as I look at that question, I find myself thinking, that's a difficult thing to decide. Because we said the more often we compound, the better we do. But this one's got a higher rate. Is it enough higher to overcome the difference in compound periods or not? It's kind of like that old expression, we're comparing apples and oranges. These are different. And so to answer this question, we use something that's called the effective yield formula. And the effective yield formula kind of says, okay, so in every year, what would this be comparable to if it were a simple interest in 1 year? And the effective yield formula is y equals 1 plus r over n to the n minus 1, where again, y is that yield, r is the rate as a decimal, and n is the compounds in 1 year. And by looking at the yield, it gives us the opportunity to compare them on a level playing field. This is sort of like that idea when we use z-scores to compare how unusual something was from different populations. We're kind of leveling the play field by looking at their yields. So we're going to use this formula twice. On one side, we're going to have 8% compounded monthly. And on the other side, we're going to have 8.25% compounded annually. And I guess I'll rewrite the formula in the middle. Y equals parentheses. Let me erase this line that I drew. 1 plus r over n to the n minus 1. On the left-hand side, my rate as a decimal is 0.08, and my compounds in 1 year is 12. So that would give me a yield of 1 plus 0.08 over 12 to the 12th minus 1. And so if we type that in, parentheses, 1 plus 0.08 divided by 12, close, raised to the 12th power, then subtract 1. I get a crazy decimal, 0.08299999. Whoop, did I put an extra 9 in there? I think I did. 3 nines, 507. Now on the other side, my rate as a decimal is 0.0825. And if I'm compounding annually, it's once a year. So that gives me y equals parentheses 1 plus 0.0825 divided by 1 raised to the first minus 1. And it gives me that 0.0825. Is everybody getting those results? If so, now we want to compare the two. And to compare the two decimals, we're going to look for the first place where they're different. And so this one, the fourth digit behind is 5. This one, the fourth digit behind is 9. And so that tells me that this is larger, which tells me that the 8% monthly is the better investment. And so if we're comparing two different investments, that would be the formula that we use.
Wait, how can you tell which one is larger?
We're comparing the two decimals. I wish I was in front of you right now because I'd have my fingers at each one. They both start 0.082.
Yeah.
First digit that differs is that next digit. One's a 5, one's a 9.
Okay.
9 is higher. And so we're just going to look at the first digit where they differ, and whichever one has the higher digit is going to give me the better yield.
Alrighty.
Okay. And if that's all right, that's the end of that homework for section, I believe it's 8.4, which deals with compound interest. Next place we're going, though, is an idea of an annuity. And an annuity is an account that you make fixed regular payments into every compound period. Sometimes you make them. Sometimes your employer makes them. if anybody has something like a retirement account where you put in so much money every pay period, that would usually be something comparable to an annuity. Because if you think about it, in 30 years, when you guys retire, if we go back to that preceding question, where in 30 years when you retire, to want to have $500,000 in an account somewhere isn't really that much of a stretch if you start saving now. But if we look at just putting money in a compound interest account, I think we all agree that we don't have that $150,000 on hand. So instead, we might want to set aside a smaller amount of money every month and have that money that's added to the account every month make interest, and that's compounded and add together. And at the end of those 30 years, we'll have our desired amount. When we look at this idea of an annuity, we're going to say that A, just like before, is that future value. This time, P is going to be each fixed payment. R is going to be our rate. Again, we want to write it as a decimal. T is going to be our time in years. N is going to be the compounds in 1 year. And we're going to have two different versions of this formula. One version is going to be if I know how much money I'm going to put aside on a regular basis. If I know how much money I want to set aside every month, and I want to know how much money I have in the future. So this formula is going to be if we know P and want to find A, we'll use A equals P times parentheses. Yes, it's important that you hit that parentheses twice. 1 plus R over N, close parentheses, to the NT, minus 1, close parentheses, all over parentheses R over N. And then the other formula that we'll use is if we know what we want in the future, and we're trying to figure out how much money I need to set aside every month, every week, whatever, to get that. And we're looking for, want to find what our payments must be. And this formula is going to be that P is equal to A times parentheses R over N, close parentheses, over parentheses, 1 plus R over N, close, to the NT minus 1. So let's look at.
Why is there 2 parentheses at the starting but 1 at the end?
There actually are 2. Your
Oh,
parentheses
okay.
match up. I just forgot to write one. This parentheses matches with this one. Over
Yeah,
here
I just saw that.
matches with this one. And then this matches with this one. Oh, isn't it fun playing with colored pens? Oh, sorry, I digress. So, oh wow, and look at the red and green. That's like festive holiday colors for the first day of December. Let's see, we've got 6 minutes left. So let's look at a problem that makes use of one of the two formulas and then pick up from there next time. And I am going to go rogue and not use the example that I have, but instead let's use that example that we looked at earlier, that we want $500,000 in 30 years. We can invest in an annuity Chris, that's the alarm I set, but we figured out some of your problems with my math lab. Don't do that homework. That pays, I want to go back. What were we getting? 4% compounded monthly? How much should we contribute every month? And again, with these, we want to round up, and let's do it to the nearest dollar. And so this time we know our future value. We know our rate. We know our time. We know our compounds will be 12 a year. So NT would be 12 times 30 or 360. And so what that means is over the course of the years, we'll be making these payments 360 times. So now we're going to use that formula where we're looking for the payment. P equals A times parentheses R over N to the NT over parentheses, parentheses, 1 plus R over N. I'm sorry, I got carried away. There is no exponent in the numerator. 1 plus R over N to the NT minus 1. So just substituting, A is that 500,000. And I have to tell you, sometimes when I type these in my calculator, I start going cross-eyed and losing track of my zeros. So be careful. R is 0.04, N is 12, close parentheses, divided by double parentheses, 1 plus that same 0.04 over 12. That exponent multiply in advance, otherwise you're going to use too many parentheses, minus 1. And I'm going to type that in the way it looks. So I'm going to do my 500,000 times parentheses 0.04 divided by 12. I'm going to close those parentheses, hit the division symbol, which gives me a slash line that looks like that fraction. Then I'm going to open two parentheses, 1 plus 0.04 divided by 12, close one set of parentheses, raise it to the 360th power, subtract 1, and close the other parentheses. And so this tells me that I would need to set aside, it says 720.4098, and it keeps on going. I want to round up to the nearest dollar, so I'm not even looking at the next door neighbor. I'm always rounding up. I need to set aside $721 a month. Is everybody else getting that same amount?
Yes, I did get that.
Okay. Does that seem more manageable if you want $500,000 in 30 years to start setting aside $721 a month? What would that be? About $170 a week, something like that? That's more manageable than throwing in $150,000 now, isn't it?
No.
No, you have $150,000.
I can't put $721 towards something like that a month.
But it would be easier than coming up with that 120 million. Oh dear. Now,
Possible.
150 million, 1,000, pardon me. I want to do more with this problem, but it's that time. So what I might do is next class, instead of opening a new file for the notes, just pick up from here. All right. So again, homework 8.1 is simple interest. Hopefully everybody's got that one done a long time ago. 8.1 is percents. 8.2 is simple interest. There's a quiz on that. Hopefully everybody's conquered that assignment. And I meant 8.3, not 8.2. The next one, 8.4, is compound interest. You can finish that one now. We've done everything with compound interest. The one after that is annuities, and we're just tip of the iceberg. Don't worry about the annuity assignment yet. All right. Let me stop sharing, stop recording.